Question number 5. By sketching a suitable pair of graphs, show that equation ln x equal to 3x minus x square has one real root. Okay, in such case, what do? We make two equations of functions out of this, so one is y equal to ln x, and second will be y equal to 3x minus x square. This one is exponential, this one is quadratic. And then we draw them separately on the same graph. Okay? So let's draw y equal to ln x. It is a very fixed graph. It passes through 1 and starts from near to the y axis and goes like this. If you are not sure how to draw this, just make a table, give some values of x and y. What will be the values of x and y? You can take hint from the next part. Next part they're saying the root lies between 2 and 2.8. So start from 0 or 1 or something and you'll get these kind of graph. Okay, if you have no idea how the graph looks like. All right. Second one is a quadratic. In this, I will first find the x-intercepts of this. For x-intercept, the y has to be equal to 0. So for x-intercept of quadratic, 0 equal to 3x minus x square. So x taken common, 3 minus x equal to 0. That means the first x-intercept is 0, second is 3. So 0 and 2, 3. These are the two x-intercept. Since the leading coefficient of x square is negative, our graph for this will open down, and these are the two x-intercepts, and we can clearly see they are crossing at one point, so the root is 1. Only one root is there. That's what we've shown through the graph. Verify with calculations. The root lies between 2 and 2.8. For that, we should rearrange the equation by bringing everything to the left side. Now, root is between 2 and 2.8 we have to show. So first we'll substitute 2 in this and see what is the sign. So in place of x, I'm writing 2. So in this case, I'm getting minus 1.3068. When I substitute 2.8, I get 2.8 plus 2.8 square, and in this case 0.4696. Can you see? This is positive, this is negative. Change of sign indicates presence of root between 2 and 2.8. Part C. We have to use iterative formula, this one, to find the solution. So the starting point, because we know it is between 2 and 2.8, the root, we'll start with x1 equal to 2.4. So x1 plus 1, 2, yeah, will be square root. The iterative formula is given to us. I will substitute 2.4, the first thing here, and minus ln 2.4. And we will use calculator to find this, which will be 2.5149. And I'll continue this till I get my required solution. So I will just fasten up this video now. And we got our answer here, because this iteration will give me, if I round off, 2.62. This is also giving me 2.62. So we keep on doing iteration till the time our required two digits are equal. So finally our root is 2.62 because of this. Question 6. The variables x and y satisfy the differential equation, this one. When y is 0, x is 0, that the additional information they've given so that we can find some constant later. Solve the differential equation obtaining an expression for y in terms of x. To solve differential equation, first requirement is that dy and dx must be numerators. Dy is already a numerator, so dx will go to the other side and become a numerator. Second requirement, the y should be with y and x should be with dx. So x is with dx, but y is not with dy. So let's break up this part first. So dy equal to x e to the power y over e to the power x. I can separate them. So now e to the power y is separated. And we'll bring that e to the power y to the left side. So let me write here 1 over e to the power y dy equal to x multiplied by 1 over e to the power x dx. Both the requirements are fulfilled now. To solve the differential equation, now we should integrate both sides. So it is easy to integrate this one because it is equal to e to the power minus y, and the integration will be e to the power minus y divided by minus 1, right? But here we have one algebraic part, one exponential part that we have to integrate. And for that, we need to use integration by parts. So in our list of by parts, we have one algebraic and one exponential. That means this will be u, this will be v prime. So algebraic x is our u and e to the power minus x is v prime. For what? We know that integration of u v prime, which is our question, prime is here, is equal to uv minus u prime v. So in place of this, we can write this. So let me do on the right side and then I'll come back to our main solution. So u is x, v is not known to us, but v prime is known to us. So v will be integration of v prime. So integration of e to the power minus x. And just like this part, we will integrate this as e to the power minus x over minus 1, which is minus e to the power minus x. All right, minus e to the power minus x minus u prime will be the differentiation of u, which is x for us. So it is just 1. V we just found out minus e to the power minus x dx. Okay, so minus x e to the power minus x, that's what we can write this one. And integration of minus e to the power minus x will be positive e to the power minus x by this method only. And because of this minus, that positive will again become negative. So minus e to the power minus x. Let's take minus e to the power minus x common, and we are left with what? X and plus 1. From this, I factored out e to the power minus x negative. All right, let's write it here. Minus e to the power minus x, x plus 1. So minus e to the power minus y equal to minus e to the power minus x, x plus 1 plus c. I forgot to write plus c here. All right, so negative and negative we can cancel out, and we can write it as a denominator. So that it becomes, exponent becomes positive. So x plus 1 divided by e to the power x. This also becomes positive when it becomes a denominator. So now, reciprocate both sides. E to the power y equal to e to the power x over x plus 1. Next thing we should do, because they're saying we have to find y in terms of x, we'll just write y, remove e. When e is removed, we get other side as natural log. Now we can separate the numerator and denominator in natural log, or we can leave our answer like this. So what do they want? They're saying expression in terms of x. Okay, done. This you can leave your answer like this. We have B part also. Find the value of y when x is equal to 1, and this is the format they want us to express it. All right. So let's write y equal to ln. Now x is 1, e to the power 1 over 1 plus 1. But the format has to be this way. So let's see, y equal to ln e over 2. So to change it to that format, we need to separate e and 2. So y equal to ln e minus ln 2, because they are dividing. When they separate, they subtract. So ln and e cancel out. That's 1 minus ln 2. So A is 1 in this format, B is 2. Moving on to the next question. Number 7. The equation of a curve is given. Show that dy over dx is this. So since x and y are combined here, we have to use implicit differentiation. Okay, so what should we do? We should differentiate them individually, but wherever we differentiate y, we have to add a suffix dy over dx. So x cubed differentiated as 3x square. Then we have 3x square y. X and y are multiplying, so we will use the product rule. 3x square prime times y plus 3x square, and y is differentiated, minus 3y square dy over dx, because y has been differentiated and differentiation of 3 is 0. Okay, so 3x square plus differentiation of 3x square is 6x, y plus 3x square differentiation of y will be just 1, but since it is y, we add dy over dx, minus 3y square dy over dx equal to 0. So we'll keep dy over dx on the left side itself. So first we have 3x square, then we have minus 3y square equal to, this will come to the right side, minus 3x square minus 6xy2, and that's it. So let's divide both sides by 3x square minus 3y square. 3x square minus 3y square, they cancel out. Dy over dx is equal to, and let me take minus 3 common out of this, x square plus 3 taken, right? So 2xy. What is our target? Is it x square plus 2xy? Yes. Over 3x square minus y square. So this 3 and this 3 cancel, but we are left with minus 1 here. And to make it positive, let's multiply by minus 1 up and down, so that this minus 1 and this minus 1, they become positive. So dy over dx equal to x square plus 2xy over minus 1 will change the signs of these two. They will change their place, y square minus x square, and this was our target. And here is the B part. Find the coordinates of the points on the curve where tangent is parallel to x-axis. Parallel to x-axis, by that they mean that it's a stationary point. This is x-axis. Anything parallel to x-axis is a horizontal line. And if the tangent is horizontal line at any point, it's a stationary point. In other words, they're asking us to equate dy over dx equal to 0. So not directly they're saying, we have to uh, take a reference from it and do this. So our dy or dx is known to us in first part, so we will do that one. So to x square plus 2xy over y square minus x square is equal to 0. When denominator multiplies with 0, it vanishes. We are just left with x squared plus 2xy equal to 0. We can factor this. What can we factor? X. So we are left with x plus 2y equal to 0. Two parts are multiplying equal to 0. That means either x is 0 or x is equal to minus 2y. These are the two stationary points where the tangent is parallel to x-axis. So now, our equation was this: x cube plus 3x square y minus y cube equal to 3. So they're saying find the coordinates. That means we have to find y coordinate also, right? So replace x equal to 0, we'll get the y coordinate. 0 cube plus 3 0 square y minus y cube equal to 3. 0 0 y cube equal to minus 3 cube root. I hope you understand. We can transfer this negative to the other side. So y becomes cube root of negative 3, which is negative 1.44 almost. So the first point where the tangent is parallel to x-axis is x equal to 0, y equal to negative 1.44. Now, this is going to challenge us a little. What will we do? We'll use the same equation again to find the x and y coordinates. So, x equal to minus 2y. So, in place of x, we will write minus 2y cube plus 3 minus 2y square minus y cube equal to 3. So, minus 8y cube, and this is 4 times 3, 12. 12y square and times y. There was y also, right? There was y. Minus y cube equal to 3. So what do we get here? Minus 8y cube plus 12y cube minus y cube, all of them cubes, equal to 3. And that is how much? Minus 9 plus 12 is 3. 3y cube equal to 3. Both cancel. Y cube equal to 1. And cube rooting both sides, y equal to 1. So we got y coordinate 1, which is not this. It is different from this. So we have to find x coordinate now. And again, we'll use the same equation. That equation is here. X equal to minus 2y. So x equal to minus 2 and y we got equal to 1. Yes, from here. So x equal to minus 2. So the second point, stationary point rather, is minus 2, 1. The first one was 0, minus 1.44. That's it.